So our bacterial environment temperature alarm has a variety of parts with 3 inputs and 2 outputs. First, we have the potentiometer, which acts as a threshold temperature dial. Turning the potentiometer changes the threshold temperature from 0 degrees to 100 degrees. As you can see here, it's currently set to 100 degrees, but when I turn the dial, it can go all the way down to 0 degrees. Additionally, we understand that the optimal incubation temperature for most bacteria that would be grown in a biological laboratory is close to room temperature, which is around 37 degrees Celsius, which is where we try to set our temperature threshold. Our second input is the temperature sensor, which allows for the bacterial environment temperature to be shown on our serial monitor. This gives a reading of the temperature of the surroundings. Our third input is the push button, which allows the user to stop the piezo alarm when it's pressed. As for outputs, the piezo emits a beeping alarm and LED flashes when the surrounding temperature is greater than the threshold temperature and the bacteria is not growing at an optimal rate. After the push button is pressed and the alarm and the LED are stopped, the reset button is used to re-enable the alarm.
The circuit has a lot of components. First is the temperature sensor, then the potentiometer, then the LED, then the piezo, then the button, and then we use also the reset button. So first thing is the temperature sensor. It's an analog input that gives the current temperature using values between 0 and 1023, and it displays it on the serial monitor. Then we have the potentiometer, which is an analog input that gives the values between 0 and 1023, and it depends on the angle of rotation. Then we have the LED, which only lights up when the threshold temperature is reached, and it's a digital output that uses the pull-down resistor. We also have the piezo, which turns on when the temperature threshold is reached, and it's also a digital output. And it's important to note that the LED and the piezo operate together, so they both turn on together and turn off together. The button is the digital input, and it uses a pull-down resistor to give a value between 0 volts and 5 volts, and it exits the loops and shut down the light and the alarm as if it's a real alarm clock. We also have the reset button, which we use it to re-enable the device after it's been shut down by the button.
Okay, so over here in our setup, we have all of the variables we need for getting temperature and voltage and the threshold max. Up here we have just general setup stuff, constants for switch state, pin numbers, and other values. Yes, so over here, this is where we start the serial monitor. This is where we print the initial statement of functional just to let us know that everything's working fine. We have all the pin modes set up here. Going into loop, we have our if statement. You'll see why we need this later. Flag is currently set to true, so this will always run. We have our button state, just checking. So if temperature is greater than threshold max, a audio and a visual alarm go off. And so for 1 second at a time, you see you hear the audio go off and you see the light flash. However, if temperature is not greater than threshold max, then nothing happens. So we just keep on reiterating over the values. Then what happens is that we print all the values so we can see what's going on the serial monitor. Then over here, if you press the button, we print escape to let us know that we're ending the program, and that flag changes to not flag, which basically means we go from true to not true. And this matters because over here, this breaks us out of this statement. So we stop checking the temperature, and we stop updating threshold max, and we stop all alarms. This basically ends the program until you use reset, which resets the value of flag especially to true, allowing everything to run once more. This works like a real alarm clock.